Up next, we have the idle air control valve, or the IAC valve. This is a valve that's controlled by the ECU or the PCM, and it allows air to bypass the throttle valve. It's located on the throttle body, in our case on the underside of the throttle body, and you'll find this on any fuel injected engine where the throttle is manually controlled with a cable. So there's various different names for this thing. You can find it called the IAC valve, which is this, the IACV, the ISC, idle speed control, ISCV, or the BAC, which was the predecessor to this one on Miatas, the BAC, bypass air control. But nowadays, thanks to OBD2, IAC is the standard term for this thing, idle air control valve. So this thing is basically the electronic equivalent of the choke. So you find a choke on an old car or garden tools like chainsaws and lawnmowers, and when an engine is cold, you open the choke to get a bit more air in there, because a cold engine needs more air at idle. As that engine warms up, it no longer needs the extra air. So that's one function done by the IAC. The other is that at idle, the engine, basically the load on the engine at idle varies. So idle speed, what are we talking about there? Well, if the driver has their foot off the throttle, the engine is just idling there, the load on that engine at idle varies. And where does it vary? It varies based on, for example, the alternator. If the battery voltage is low and the alternator's working hard, the alternator applies a bigger load to the engine, so we need a little bit more fuel, a little bit more air to maintain a nice smooth idle speed. Likewise, we might find that air conditioning is on. If the air conditioning is running, then again, we've got a bigger load on the engine. The power steering pump, for example, if you're turning the steering wheel while the engine is idling, again, that applies greater load to the engine. So the ECU monitors various inputs and adjusts the amount of air that bypasses the throttle valve. Now, we looked earlier and we talked about this idle air orifice, this small hole that runs from one side to the other side and bypasses the throttle. But that just allows a fixed amount of air across. There's always an airflow through there, but it's fixed, it doesn't vary. The IAC, this valve down here, is a way of additional air being allowed to bypass, determined by the load and the temperature of the engine. So how does it work? Well, inside this housing down at the bottom here, in fact, let's pop this thing off. Let's see how this thing works. There we go. What we see is on the bottom of the throttle body housing here, we have two holes. If we look inside, this is the intake side of the throttle body, so we have our air flowing in this way. We have down at the bottom here a nice big hole that drops down, comes out here, and that runs into, if you imagine the air comes down through this hole, comes into here. Inside this housing, we have a solenoid, so you can see what looks to be some sort of protective accordion type thing, a seal on there. But inside here we have a solenoid which operates a valve, and that valve determines how much air passes between these two holes. So the air comes down here, goes into this hole, the valve determines how much air passes through, bypasses, so the air comes out through this hole, back in here into the bottom of the throttle body, and you'll see this hole runs all the way through, comes out here, and then into our intake manifold. So basically we're controlling the airflow between these two holes using our IAC valve. So what's inside here is, as I said, a solenoid. On there is a valve, and the solenoid's position is controlled by the ECU. Now, on a normal engine, this position is controlled by pulse width modulation, or PWM. We've talked about this before. So the actual current that flows into this solenoid is what determines its position. But because we're controlling electronically, we can pulse electricity into the solenoid for various periods of time on a duty cycle, and that will set the position of the solenoid. So this is controlled by PWM, essentially based on the duty cycle. So if you imagine we have a duty cycle of 10%, i.e. the electricity to the solenoid is only being turned on 10% of the time, then the solenoid is going to tend to be at its closed position, or its de-energized state, mostly. However, if we pulse that very, very quickly, 50% of the time, it's effectively, from the solenoid's point of view, half of the current that it would see at 100% duty cycle. So just bear that in mind with these, is that what we're looking at is PWM control. The previous design, or the earlier designs of these that weren't controlled by ECUs, there was still a requirement for this idle air control. This might be what's called an automatic choke, maybe you would hear it called that. But the predecessor to this was a BAC bypass air control valve, and that consisted of a wax pellet, a bit like a thermostat, and we had coolant. We still have coolant flowing through here, but the coolant that flows through here is just to keep the throttle body hot. However, with the predecessor valve, we had coolant flowing into this IAC valve, into the BAC valve as it was called then, and that coolant, when it got up to temperature, melted a wax pellet and closed this bypass valve. So the bypass was controlled mechanically almost by this wax pellet, like a thermostat essentially, but controlling the flow of air past the thermostat. What we can do is we can show this thing in action. So I've grabbed the connector for this, chopped this off a wiring loom. That now enables us to connect into here. Now we've got a solenoid inside here, we already know that. Does it matter which way we connect a solenoid? No, it does not. Doesn't matter. So we don't need to worry about which way these wires go. We're just demonstrating here what actually happens inside here. So we've got a bench power supply over here. As we turn the current, you can see inside here, let's turn up some voltage, give ourselves, that's amps, well, let's go there. Okay, we're going to look for some sort of reasonable voltage. Do we see? Yeah, absolutely, we see movement inside here. As we rotate this around, turn this up, give ourselves about 1 amp, that seems reasonable. Let's limit ourselves to 1 amp, something around there. There we go, 1.2 amps at 12 volts, that's probably about right. Rotate this around, there we go. Let's take a look inside, and what we see is, as we control the voltage in and out of here, the valve opens and closes. Not a huge range of movement, but then we're not talking about a huge amount of air.